let's read about this point. To prevent the conductor damage from bending caused by its own weight and external loads, carefully position couplers. Welding and bolting can cause appreciable loss of conductor strength in the intermediate coupler locations. Consequently, position couplers where the least amount of bending will occur. So this the ideal locations are the points of zero bending moment along the conductor. So, sorry, team, wait. So let's see here, team. The quantity of conductor spans. So how many conductor spans are there? 1, 2, 3, 4, 5, 6. If I am having 2 conductor spans, the ideal coupler location measured to right from the left at 0.75 L and 1.25 L. These are the ideal locations for the couplers, to place the couplers. And now, in our case, we are having equal spans of 5. So this is our case. 0.78 L, 1.268 L. So 1, 2, 3, 4, 5, 6, 7. So this is the case we have to choose for the placement of the couplers. That's what we given here. So this 7 will come from that. 0.78 into 9.14. So this all will gives you the placement of couplers from right to left. At 7.2 meters and again at 11.6 meters, 16.3 meters, 20.1 meters. So you have to place the couplers. These locations you can see in this figure. 2, 4, 6, 8. So the conductor lengths are cut as required to the position of the couplers at these approximate locations. We have to cut the conductors based on this locations. And we already talked about this alien vibration. Depends upon the cases, we will use the dampers, otherwise not required. If it is a span length is more than 6 meters, we require a dampers. But as this is a rigid one, no need of dampers mostly. We will not consider the dampers. If it is a strain bus, then we require the dampers. Team, understood? Any doubts here? Any doubts with the coupler? Anything? Please. I hope you understand the concept and these things. If you just go through again this exercise, then you will be able to catch up the point. Please, if you have any doubts, please ask him. Maybe I am moving in a fast. So that's the reason. If you have any feedback, anything, please let me know. Yes. The project. Yes. So I request you to do this busbar sizing for our project team. So we are having 33 bar 220 kV substation. In the 33 kV, you know that we are having 1, 2, 3, 4, 5 feeders. These 5 feeders are connecting to a bus. Take the bus length of each is 6 meters, right? 1, 2, 3, 4, 5, 6. Let's take the bus length of 30 meters. Okay. And 33 kV. The current rating is 100, means 1750 amps is the current rating required. And the short circuit level you already know, 25 kA. And the face-to-face clearance assumption could be, you can select for the 33 kV, right? So 200 by 526. Yeah, you can select 400 mm is the spacing you can select between the two conductors. And now assume with a force equal spans 30 divided by 4 and do this exercise. If you are if you are really having a time, please do this exercise. And okay. So this is about the rigid busbar sizing team. So again, it's a simple, I am giving a glance that I am calculating the conductor selection. I'm doing the conductor selection. I am calculating the forces that are acting on that conductor, like short circuit forces or short circuit forces and wind loadings, ice loadings. Based on that, I am calculating the span length, and the span length will gives me the what is the maximum span to be maintained between the two structures. But it is not limited with respect to that. Again, we have to calculate the deflection factor, where you can find the actual the span length. So after that, I am calculating the cantilever strength, followed by thermal expansion, and then placement of couplers. This is the conclusion for this. I am sharing you the this calculation one, supporting this presentation, and I request you to do this exercise for our 33 kV system, or let's assume any project, and let's do this. And if you are doing for the same example in this notebook also, absolutely fine for me. But check where it is, which one is affecting the what. That is the thing you need to know. Remaining not at all required. No need to by heart the formulas, no need to memorize the formulas. Just flow, and which one depends upon what. Like the span. If I'm asking you that, how you are calculating the minimum span required, maximum span maintained. So it is depending upon the forces acting on the grid on that one, and also it depends upon the fiber stress of the system, fiber stress of this conductor, and also it depends upon the some multiplying factors, which depends upon the type of connection, whether it was laid with two fixed supports or only supports, one fixed, one support. So it depends upon that. And if I ask you how you're calculating the cantilever strength, my cantilever strength depends upon, again, the forces. One is the short circuit force, other one is the wind force. Whatever the deflection depends upon the weight of the conductor and weight of the ice. So this is the case. And what is the criteria for the deflection factor? 1 by 200. 1 is it required. 1 by 200 of the span length. Maximum permissible deflection. That's it. Simple. Am I clear, team? Yeah. Thanks. So I want to take this strain bus also, but I don't want to I don't want to continue now, because again it will create some confusion for you. Short circuit forces is Rajesh, you just recall our school days. There we discussed some concept of Coulomb's law, force of attraction. The force of attraction between the two charged bodies depends upon the product of their charges and inversely proportional to the square of the distance between them, right? So the same thing, that is the force of attraction or repulsion. That is the short circuit forces. Yeah. So I want to I'm having a time, but I don't want to continue the class because the strain bus is much difficult. So we need to figure out this in a detail. So this is the suspension insulator, and these are the things we have to calculate the conductor sag in this. So I will continue this in the next class. I don't want you to confuse here. It will take only 20 minutes, but anyway, I want to make it in a next class. So so that's for today, team.